Bismillah Rahman Rahim. Today we are going to start probability distribution. Probability distribution means we are starting a discrete probability distribution in which we have three main kind of distribution by using uh, uh, a binomial distribution on one of them, and Poisson distribution, and third is a hypergeometric distribution. The main purpose of these distribution to make the pattern of probability pattern and distributions by using discrete nature of data. So first of all, binomial distribution. Binomial distribution, we have four main properties of binomial distribution. First is a trial has only two possible outcomes, so like successes or failure. The main purpose of this property assumption is to uh, see the scenario where we have two possible occurrences, two possible outcomes, two possible, just like pass or fail, just like defected or not defected, just like disease or not disease, just like absent present, just like any kind of things is running or not running, true or false, like this two possible outcomes from any experiment, any we are going for the trial. So next is there is fixed number of there is fixed number of trials are fixed. So when we are rolling a die or we are tossing a coin, we have to know before the experiment how many coins you are going to toss and how many dice you are going to roll. And we have to understand before that, like what is your sample, like what is your n. So we have to identify in the prior of before start of the experiment. The third is the trial of the experiment are independent of each other. Like we are tossing like two coins, and we knew that before. Each of the coin are mutually exclusive and independently. If we are tossing a single coin, and if we are tossing once, we are getting head, and again we are tossing coin, again maybe we are getting head, again we are tossing, we are getting tail. So all the events are performing independently. The outcomes of the any trial are independently from each other. So the fourth property is probability of success is P remains constant or remain fixed for each trial. So it means that we are tossing a coin, even we are rolling a die, even we are playing a cards, and even we are doing any kind of experiment. We have to know that probability of each of the trial must be the same, and you can say the probability of success remains constant. The last simplest concept is P is a probability of successes, and the opposite of P is Q, small q. So small q is known as probability of failure. Probability of failure, the probability of successes, mostly we uh, um, the probability that the targeted suppose you are you want to find the probability of failure students. So maybe your failure student as a success baby, because you are supposed to check the failure probability, and maybe you want to find the defected parts. So maybe defected part as a successes we can use. So it doesn't mean that you are going to for the good way, like passing, corrected, and the true, and all the things. This is not, we can assume that this is successes. Successes maybe happen as a failure, maybe happen as a like any kind of probability that you have targeted and you want to find the probability for particular event. So next is the basic concepts, like the same we have discussed in that, like maybe a marketing research firm receives survey responses of yes, I will buy, or not, I will not, like maybe buy or not. So we have two possible outcomes. That's why we can say that success or failure, it lies in this example. So here is a combination method. I will you can convert it by using calculator directly. NCX is equal to n factorial divided by x factorial into n minus x factorial. So directly we are coming to use the formula. The formula is very simple. I'm using drawing. The formula is the easiest formula that you can use for any question, like NCX. So this is the same exactly I have converted in this, and p power x, and the next is 1 minus p power n minus x. Everyone, you can write down this formula. This is very simplest and the easiest formula you can use in any kind of person. If you have a paper or pen, you have to write down this formula. Now this is very simplest formula. Like we have an example in down, like in the left side or right side, you can see flip a coin 4 times. Like 4 times means n is 4, like p n as a 4. So x is the number of heads. Like we knew that the probability of head and tails are equal, like 50% chances for the head and 50% chances occurring for the tail. So if we want to find the probability of one head, like one x is equal to 1. So just we are putting the value of p and the x value, x is 1. So n is 4. So x is 1 and p is 0.5 and the x is 1. So again 1 minus p, 1 minus 0.5, and the power is n minus x, and 4 minus 1. This is 4 minus 1. So just we are going for the solving 4C1 is 4. Every calculator have the options of the combination sign. So 4C1 is 4. You can see the a sign of on Casio and any kind of scientific calculator, NCR. Find the button NCR. NCR means combination of N with R. So 4C1 is 4, 0.5 power 1 is 0.5, and 0.5 power 4 minus 1 is 3. So is multiplied by 0.5 power 3, right? So just you have to multiply those values. You can get the probability of one head when we are tossing 4 coins at a time. So by using binomial distribution, we can get the probability in the easiest way while we are going for the formulas, individual formulas. That would be like a very complex method by using one by one probability that you have seen in the last chapter, and even the 5.1 exercise by using business statistics by Grobner. So uh, this is the easiest way to find the probability by using binomial distribution. One of the example I have performed. In the next example, I have also many things to guide you. So just hold down for the next thing. So see that the next is when we have n is equal to 5 and probability is 0.1, then you can see the diagram of binomial distribution is by using different bars. Because it's a discrete probability distribution, you can see that every point have the bar. So in the continuous probability distribution, we cannot draw like this. In chapter number 6, you will be learned by using continuous probability distribution. So if you are using n is equal to 5 and p is equal to 0.5, then you can see the diagram. So here you can write down the formulas like mu is equal to expected value of x is
सर
equal to n.
स्क्रीन नहीं शो हो रही.
I just see that. So you can see that.
Yes sir.
Okay, thank you. You can see that like mean value of the binomial distribution is np. As you know that we also can say expected value of x and the mu. The mean of binomial distribution is np. N is the trial, and p is number of probability of successes. And the same like formula we have sigma square as a variance. Like you can say that this is as a variance, this is as a standard deviation. So npq, you can say that q is opposite of p. Like if you have p is passing, probability of passing of the student that in any specific class is 80%, suppose that. So what we can say like 0.80. So probability is 1 minus 0.8, and what is coming as a q? Probability of failure is 0.2, means 20% chances of failure if the probability of success is 80%. So a very easy concept, P and Q, probability of successes and probability of failure. So in the next step, you can see that we are going for the next step. The next step is, just a minute. Yeah. If we have n is 5 and probability of success is 0.1, then you can find the mean and standard deviation. The mean is n and p. Just we are getting, just we are multiplying the p and n. You can see that the probability is 0.05 and n is equal to 5, 0.01 and n is equal to 5. So just multiplying by n and p, and we getting 0.5. And the same like standard deviation of binomial distribution is square root of npq. Just we are multiplying 3 of the npq, and we are getting the answer is 0.67 as a standard deviation of binomial distribution of x. Another example, you can see that like n is 5 and probability also 0.05, and we getting the multiplicative multiplication of n and p, and the value is 2.5 is the solution of a mean of binomial distribution. And the standard deviation is square root of npq, and the answer is 1.118. So finally, we have seen that you can get the mean, variance, and standard deviation just if you have n and p in the given situation. So we have another example to guide you. Okay. So next is we have example, a binomial distribution example. 35% of all voters supports proposition A. Like 35% voters are supporting a particular party, a party A. If a random sample of 10 voters is pooled, what is the probability that exactly 3 of them support the proposition A, like party A? In the easiest word, I can say in the Urdu I am explaining. 35% चांसेस हैं कि किसी एक खास पार्टी को वोट दिया जाएगा एक खास एरिया में. If a random sample of 10 voters is pooled, यानी कि 10 लोगों को, 10 voters को हम उस खास एरिया में से सेलेक्ट करते हैं कि वो उसकी राय पूछते हैं कि कितने % वो वोट देना चाह रहे हैं. Like what is the probability exactly 3 of them support the proposition A, यानी कि 10 में से 3 जो है उस वो खास पार्टी को वोट देना चाहते हैं. तो इसका मतलब है कि अगर हम चेक करना चाह रहे हैं कि 35% जो चांसेस हैं कि वो, इसका मतलब P आपके पास जो प्रोबेबिलिटी है वो आपके पास क्या आ गया 35%, राइट। सो उसके बाद आपके पास 10 वोटर जो है वो, इसका मतलब N आपके पास क्या आ गया 10%। अब क्वेश्चन पूछा जा रहा है एग्जैक्टली थ्री के लिए आंसर निकालना है, तो ये आपके पास 3 के लिए आंसर निकालना है, x इज इक्वल टू 3 फाइंड करना है। सो आप देख रहे हैं कि जस्ट आपने उस फॉर्मूले में जो बाइनोमियल डिस्ट्रीब्यूशन का फॉर्मूला था उसमें हमने ये चीज अगर आप 1 मिनट के लिए भूल जाइए, कैलकुलेटर आपको डायरेक्ट आंसर दे देगा इसकी। आप अगर आप कहें कि जस्ट NCR आप लिख दें, NCX, और कैलकुलेटर आपको आंसर दे देगा। जो ही कैलकुलेटर आंसर देगा आप जस्ट P की वैल्यू और लाइक 1 माइनस P की वैल्यू पुटिंग कर दें और इसकी पावर्स जो भी हैं N और X रख दें और आपका आंसर आ जाएगा 0.2522। इसका मतलब है कि 25.22% चांसेस हैं कि उस एरिया में उस लाइक जो प्रोपोजिशन है उसके जीतने के ये चांसेस हैं। यानी कि आप इलेक्शन से पहले अगर आप कुछ इस तरह का एक्सपेरिमेंट कर लें तो बाइनोमियल डिस्ट्रीब्यूशन आपको बता देगी कि कितने % चांसेस हैं कि वो खास पार्टी को जीतने के कितने % चांसेस हैं। तो ये प्रोबेबिलिटी के जरिए आसानी से निकाल सकते हैं। सो मैं एक दफा दोबारा से एक रिपीट कर रहा हूँ, अगर किसी स्टूडेंट को पूछना है तो लाइक 35% चांसेस हैं कि वो ये खास पार्टी जो प्रोपोजिशन ए जो है उसको वोट मिलने के ये चांसेस हैं। अब या फिर पास्ट रिकॉर्ड, पिछले साल का रिकॉर्ड आप देख लें, या फिर आप करंट सिचुएशन देखते हुए कुछ वोटिंग प्रायर कलेक्ट कर लें तो वो भी आप ठीक रहेगा। 10 वोटर्स आप सेलेक्ट करें। 10 वोटर्स का मतलब है N आपके पास 10 है, तो लाइक मैंने एरो बना दिया, N आपके पास 10 है। तो 35% चांसेस मीन P आपके पास 0.35 है, N आपके पास 10 वोटर्स हैं 10 है, और 3 उसमें से सेलेक्ट किया जा रहा है, वो आपके पास x इज इक्वल टू 3 जो फाइंड करना है आपने। सो आप जस्ट फॉर्मूले के अंदर वैल्यू पुटिंग करें और आपके पास आंसर आ गया 0.2522। आपके पास जो आंसर आया उसको हम परसेंटेज में कन्वर्ट कर लें मल्टीप्लाई बाय 100 करके, तो लाइक 25.22% चांसेस हैं कि आपके पास उस खास पार्टी को वोट मिलेंगे उस एरिया में से। सो आई होप you got the point. If you have any question you can ask. Yes, Assalamualaikum again. Like we are going to continue binomial distribution by using MS Microsoft Excel. So first of all, I want to tell you the code like function of binomial distribution. First, you have to like say that you have to enter equal, then by norm dist. This is the key function. Like you can say that Excel will perform binomial distribution by using this function, equal binom dot dist distribution. So first of all, you can see that here is the binomial distribution dimension number s. Number s mean x value. First, you have to define the x value. Where is your x now? The same question that you have seen in the slides. I'm solving the same question for you. The first is I just sharing the screen for you guys. Okay, everyone. Maybe you have seen the slideshow in the right side, and the left side is this Excel sheet. So first of all, we are performing binomial distribution, the same question that I've asked about the proposition A, the winning chances of a particular party. The binomial distribution is solving the problem by using Microsoft Excel. So number S means like the x value, x is 3. So like just write down the 3, comma. Now trials are 10, n is equal to 10, 10 is trial, like 10, comma. The probability is 0.35, like 0.35 is the probability, then comma. Then it's very interesting point. Here we have two options. The one option is true and the second is false. Which is like more better, more suitable. The here is we want to find the exact probability. X is equal to 3. Then we have to use false. Like again, I'm repeating. So here we have used false as a statement. So false means we are just using the specific probability, and we are using x is equal to 3. Means we are just finding the probability of 3 successes, like 3 occurrences out of 10, with the probability of 0.35, like 35% probability, and like voters are 10, and the chances of occurrence is exactly 3. Then the probability, just we are going for enter is, sorry, here is something wrong, binom 3 false. So yes, false is maybe capital in it. So the same probability, 25.22% chances for specific condition, specific scenario. So we have two more options for the binomial distribution. The first is just if possible. I want to tell you, we are going to find the probability of x is, sorry, probability star x is equal to 3. Just we have this formula. If we want to find the probability of x is less than 3, less than or equal to 3, then how we can perform? This is x is less than and equal to 3. It means we want to find the probability of 3 or less than. 3 or less than means 3, 2, 1, 0. Like we want to find the probability from 0 to 3. Then how binomial distribution helps you? So just equal binom, binom dist, and now 3 comma the same 10 comma then 0.35, then 2. So why we are using 2? Because we want to find the cumulative probability. Cumulative probability means we want to find the probability from 0 to 3. Then you have to use binomial distribution. So just going for the enter, and we are getting answer. So is the simplest way to find probabilities by using Microsoft Excel. So probability of again x is greater than, it's another way, greater than equal to 3. So how we can perform this probability? Just by norm and binom dist 3. Be careful, we are using 3 or 2. So here is a small condition we have to use. If you want to find the probability of 3 or more, then we have to calculate less than 2 or less than 2, and we are subtracting 1 minus probability of 2 or less than 2. I'm explaining in detail uh, after performing. 0.35 comma 2, and so here is 1 minus. 1 minus we are performing for x is greater than and equal to 3. So just you can get, sorry, here is 2. Oh, sorry, here is comma. So just you enter and you can get the answer. So if you have any question, please ask.